compounds that had two different elements in them, metal and non-metal. We saw how to name binary compounds with monovalent metals and also how to name binary compounds with multivalent metals. So today what we're going to do is take a look at how to name something called a ternary compound. So a ternary compound is a compound that has more than two different elements in it. It might have three different elements in it, for example. So ternary compound. Another way to think of it is ternary compounds are ionic compounds, so they're still ionic. They have a metal in them. There's an attraction of oppositely charged ions. So it's an ionic compound with something called a polyatomic ion. A polyatomic ion is not a compound itself. Instead, it's a group of atoms that are covalently bonded, so they're attached by covalent bond, pairs of electrons, and they have an overall charge. So for example, nitrate is the polyatomic ion NO3 with a charge of -1. Carbonate is a polyatomic ion CO3 with a charge of -2. So there are a variety of different polyatomic ions, and there are some common ones that need to be memorized. So you need to be aware of many of the common ones within this table here. There's a great little trick you can use to remember some of the common ones, and it's over here. I'm just going to walk you through it briefly. So you'll notice the first word here is Nic. The N is the first letter of the polyatomic ion, so N. And the consonants, so N, C, K, represent the number of O's. And the number of vowels represent the charge. So there's one vowel, so that's -1, just like that. So if you remember this saying, then what you can do is you can use it to remember some of the basic compounds. Here you'd have carbonate, bromate, fluorate, so on and so forth. So we're going to start off by naming, and afterwards we're going to write formulas for ternary compounds. So let's say that we had C, oops, that's a bit thick there. Let's say that we had CaCO3. To name a ternary compound with a polyatomic ion, all you have to do is name the metal, name the polyatomic ion. Our metal is calcium. Our polyatomic ion is CaO3 2-, so calcium carbonate. Metal, followed by non-metal, followed by polyatomic ion, not non-metal I should say, polyatomic ion. Do not change the ending. Polyatomic ions, they'll have endings ate, ite, or sometimes yum. That's how you know you have a polyatomic ion. So let's do an example where you have to make a formula from a name. So let's say we had calcium nitrate. Your first step is to write the ion symbols side by side. So calcium is in group 2, it has a +2 charge. Nitrate, if we go up, is NO3-. That's from my table there. Now you're going to do the crisscross or charge balancing. It doesn't really matter which one, but here's a point I want you to get. Put your polyatomic ion in brackets and put the charge on the outside. That's because you cannot change anything about your polyatomic ion in terms of its number of atoms. If you move this 3 by accident, then it becomes something different entirely. So you always put your brackets surrounding your polyatomic ion so you can protect it, so you don't change it during the crisscross or reverse crisscross method. So your 2 can go down here outside the bracket. Don't put it in the bracket, otherwise it becomes NO32, which is not NO3 anymore. The 1 comes down here. And so we get Ca1, but you don't have to write it down because it's 1, brackets, NO3, close bracket, 2. So what this means is you have 2 nitrates and 1 calcium. You could have done the charge balancing method. Ca plus 2, nitrate is -1. The only way to get 0 is to have another nitrate, because it's -1. So -1, -1 is -2. Plus 2 is 0. So you'd have 1 calcium. The subscript does not indicate the charge, it indicates how many you have. So 1 calcium and then 2 nitrates, each with a charge of -2. The same process would occur if you had multivalent elements within these compounds. You have to take that into consideration. So let's do the example of lead 2 carbonate. We'll do lead 2 carbonate. So again, write the ion symbols side by side. Lead 2. You would have also seen it called plumbus if we were using the Latin system. So L Pb plus 2. Carbonate, if you go look at your table, is CO3. So I'm going to protect my polyatomic ion, only put the charge on the outside of the bracket, -2. If you do charge balancing, you're basically done. You'd have 1 Pb, 1 CO3, so you just write PbCO3. But if you don't, you like to crisscross instead, we'll do that. So crisscross outside the bracket, and we get Pb 2 CO3 2. Because this is still considered an ionic compound, since it's an attraction between opposite charges, the positive lead and the negative carbonate, you still have to do reduction. Divide by 2, divide by 2. Do not divide anything inside the brackets. Even if there was something that could be divided by 2, you wouldn't if it's inside the brackets. And we get PbCO3. When there's no other number outside the bracket, when there's only a 1 basically, you don't have to put the bracket there. So this is our lead 2 carbonate. That's an example of how to write a formula based on a name provided to you. You should be able to do this for a variety of compounds. The more you practice, the more you'll become comfortable with what the names of the polyatomic ions are. So make sure you review the polyatomic ions in this table and how to apply the rules we just learned. You'll notice there are some polyatomic ions that are positive, like NH4+, which is ammonium, not ammonia. Remember that, not ammonia. So you might have a compound that looks something like this. NH4, Cl. You would simply name your polyatomic ion without changing it, ammonium. And then you name your nonmetal. But you'd have to change the setting to chlorine, from chlorine to chloride. So all the rules essentially still apply. The only thing you need to remember is that you're not changing the endings for the polyatomic ions. You're leaving them as they are. Some polyatomic ions might have more than 2 elements in them. So for example, you might have Ca, H, CO3, 2. You'd have to find your metal first, which is calcium. Name that. And then the name of your polyatomic ion. This would be bicarbonate if you look in your table. In some cases, you'd have to do reverse crisscross to find the charge of your multivalent metal if you had one, and you'd apply the system applied.